So just to recap to the what exactly we learned. Okay, so we discussed about the LVM. So what is the LVM? Why we are using the LVM? And what is the structure of the LVM when compared to the Windows? Okay, especially some of the terminologies. What is the physical volumes? What is a volume group? What is a logical volume? So these are the different types of the terminologies we are using at the time of the processing. Physical volume is nothing but it's directly connected to the your hardware. Nothing but your hardware we can divide it into small portion of areas. Every hardware we can be treating as physical volume. So volume group is nothing but it is a kind of mechanism collection of PVs we group together, we are creating the volume group. So volume group become the another virtual storage pool. Nothing but it act like another virtual hard disk. Okay, so logical volume is nothing but basically it is a portion of area like your C drive, D drive or something. Okay, which is created from the volume group. Usually in Windows mechanism, if you created anything means it will be directly creating from the your hardware, means your hard disk. But coming to here, instead of you are touching to your hard disk, we are creating from the volume group. So what is the basic need we need to create means dynamic expansions, dynamic movements we can perform by using the LVM mechanism. Nothing but if any production things are going on specific weekend, if you want to perform any kind of activities, on the moment of the time what it will going to be happen, let be you want to add the some space, add the some storage, in the time we can perform the things by using the those mechanism. Second thing is that mkfs is nothing but creation of the file system. So as per the Unix mechanism, especially into the Linux, we are having the four type of the file system: ext2, ext3, ext4 and xfs. ext2 to ext4 is the basically fundamental, it is supported from the Red Hat 6, RHEL 6 and before RHEL 6 and less versions. RHEL 6 and less version, majorly we are using the this version. Whereas XFS mechanism something like that, this is advanced features we are using from the RHEL 7 and onwards. So RHEL 7 onwards we are using the XFS mechanism. But what is the major differences here? Both of them means the XFS mechanism, it is supporting the most of journaling capacity and advanced features like virtualization, those things and all. Whereas your ext2 file system is supporting majorly into the some sort of, especially ext4 only supporting little bit of journaling and other things are not supported. So what is a journaling? So journaling is a kind of the concept where it will capture the all the your audit information of your file systems. So journaling, it capture all your file system audit info to enhance and keep track system kernel use these things at syncs the file system today, and then we'll sync up and do the file system up to date. And not only that one, it will going to take up for any repair mechanism we will use this. Example FSCK file system check. I will tell you what is the FSCK going forward. Nothing but simple words. If you want to say that there is one file system will be there in Windows, let it be C drive, D drive. So at the time of the booting, you got some issue. Nothing but your file system is not mounted, or you got some issue. It is not properly mounted, or some of the files are missing. Immediately, the kernel will going to be use a journaling mechanism. It will do the FSCK. FSCK is nothing but it is a kind of the mechanism. It will help you to check the file system information. It will check the file system information. It will repair the file system. And the mount is a mechanism of mounting of devices. See, once we created the drivers or disk, so automatically it will be mounting to the your destination server, because the destination server only you are able to do the things. For example, df-th, you can see that. So this is your source, this is your destination. So both of together, if you want to club together, means we need to use the command called mount. Mount space source and the destination. So this is what we used to do that. Like a mount space source and destination. That is the command for the mounting of the devices. Okay. So then there is one more thing is there. df-th. So df-th is a command. It will help you to list out your file system details. T is nothing but the type, and H is nothing but hexabytes. So it will list out to your server whether it is a TXT format or XFS format, or TMFS is nothing but temporary file system. It is a temporary file system. It is loaded into the your server. So lsblk is a command. By this command we can able to find out list of block devices. So what are the block devices? The block devices lsblk. So by this command we can able to find out what are the list of the block devices are there, and what is the things are mounted. Block devices means, again I'm saying that it is the your hard disk portions. Your hard disk, whatever your hard disk is there, you are created into small portions. Those portions we are calling as a block devices. Those how many parts are there, everything we can list out by using the lsblk. lsblk is the command to get the information of your block devices. Got it? So there is a one more command is the pvs. pvs is a command to display the your physical volume. Since we are discussing about the pvs, lvs, vgs, how can you find out whether those are added or not? By using the command called pvs command. So by using the pvs, you can see that there is a one disk is added. You can see that volume group is this is the one, and this is the type of the command. Attribute is nothing but how many things are there. I will show you that one, and the size of the thing. And right now, do we have any free space or not? Right now we don't have the any free space. Nothing but 20 GB is a free, means all 20 GB I used into the my server level. VGS is so PV display is the enhanced command. Means PVS command will give you the shortest information of information, whereas PV display will give you the full-fledged information of your server. Nothing but particular file system, what is a file system capacity, and each and everything. See here 4 MB is nothing but PE size. Means every storage area, it is divided into PEs. PE is nothing but physical execution. But how many each PE is nothing but, for example, you have a 1 TB of terabyte of hard disk. The hard disk, your operating system will think you that it is divided into small portion of PEs, like a one Excel sheet type. like a C0, D0, C0, A1, something like that. For example, if you want to see that, so let it be your operating will system think you that let it be this is a 1 TB file. So all the data how it is going to be placing and how it is going to be pulling the information. If this is a call PE1, okay, this is called PE2, okay, this is called PE3. Like this the data will be managed into the your hard disk. If PE capacity is that 4 MB, how many PEs are there? You can see that 4863 PEs are right now, and everything is allocated. There is no PVs are free now. So you understand that PE is nothing but a small portion of the area which is allocated into the storage. To store the data, we are using the concept called PE mechanism. Okay, you got a point, right? So next thing is the VGS. So what is a VGS? So as I said you earlier, PV is the command to display the information. VG is a command to display the content of volume groups. The volume group is a collection of the PVs. You can see that this is the volume group name. This is how many PVs are there, how many LVs are there, okay, and what is the size, and do we have a space or not. So this is the shortest form of information of VGS. We want to know the in detail. So in the time we are going with a command called VG VG display. So the VG display is the full-fledged of the command. It will list you out the information of all the details of your volume groups. You can see that this is a volume group name and this is a format, and these are the read and write and resizable, and the capacity of the thing, what is the PE size, how many PEs are there, and allocated and the full PEs, and this is the one is nothing but is something like our Aadhaar card and card number type. So every volume group is operating system identifying by using unique number. So this is the unique number allocated to the 0L. So this is a unique number allocated to the 0L, and it will be identifying from the 0L. So this is the way how your operating system is calculating and moving up. Okay, so there is a one more command is called LVS. So what is a LVS? LVS is a kind of the command. It will help you out to list your logical volumes. For example, your server will be having some sort of the logical volumes. Those logical volumes information will be displayed with the content here, LVS. So this LVS will be help you out to list your logical volumes. So if you want more details means LV display. So LV display is the command if you want to display the content in more elaboratively including the properties. So coming to here, this is for LV full-fledged path and a particular name and volume group name. Every VG how it is having the unique number. Every LV also will be having the some unique number. This is the LVUUID, and it is a readable and writable, and what exactly the details and the host details it is available. So this is the full-fledged details of the your LV. So there is a one more command is called fdisk-l. So fdisk-l is a one of the command. It will help you to execute the content, nothing but for example once your disk is there, it will be automatically allocating the space. For example, you can see that here what are the raw disk are there, whatever we are listing LSBLK, this is the shortest form. In fdisk-l is something like that. it is the longest form, nothing but it will include all the properties, everything it will be listing out. Whereas LSBLK, it will list out the shortest form of information only. Every skypanel will be listing of your the longest form of your information, nothing but, for example, how many disks are there and what are the properties, nothing but how many sectors, kind of the logical information of particular thing. Okay, so let me move to the topic. So yesterday we discussed about something, right? Okay, now this is the what exactly. Let's go to the topic. So I got a requirement from the user stating that, okay, so there is a one file system with Aura we need to create. Okay, first of all, Aura is a one of the file system I need to create into the one of the server, and the file system type is ext4. Ext4 is a file system type, and the expectation is that the client clearly said that create a file system with a capacity of 5 GB. Create a file system with a capacity of 5 GB. So now the requirement is that once we receive the thing, first we'll go to the server. We are checking off if config -a whether this is the IP address or not. First I'm validating the things and all. Okay, this is the IP address, server IP address. Then I'm going with the next value. Next I'm going with, as I said you earlier,